Okay, so even though you're watching this on a video and you can pause and take things at your own pace as you're taking your notes, I do still want to go ahead and discuss what's going on here. So as we take a look at it, we are going to start with this do now. You have a chance to fill it in because of how this is presented. List the types of waves that you know. So go ahead and do that. Okay, when we're talking about waves, our objective is that I can identify parts of a wave and list several types of waves. To begin with, we want to define what a wave is. You're going to want to add this definition to your notes. You have a note sheet that's associated with this. Periodic disturbance in a solid, liquid, or gas as energy is transmitted through matter or empty space. And so that's what's known as a medium. So we're looking at, when this is periodic disturbance, we're looking at how it moves. And so it's causing a disturbance not at every single moment, but over a space or over a period of time. And then it's moving through one of the forms of matter, or it could be through empty space. We're going to talk a little more about that. Okay, so writing this down as well, waves transfer energy to any object in their path. And so this is like boats or ducks bobbing up and down in the water. Let's take a look at what that looks like. Got some boats right here. Some boats right here. I'm going to blow this up. So we can see as these waves are coming by, you can see the water moving and the boat rocks back and forth. So that is in fact waves as we're seeing them moving. Okay. So a medium, that's the actual environment in which a wave can move through. It could be solid, liquid, or gas. So that is the plural of media is going to be the plural of that. So we're just looking at the physical environment, the thing that it's actually moving through. Mechanical waves need something to be able to travel through. So for right now, you're actually hearing me speak. So that's an example of a mechanical wave. That's sound. There's no particle to vibrate, then there's no sound possible. So if I was trying to speak to you in outer space and I'm not wearing a spacesuit, you would not be able to hear me. You'd hear nothing. You'd just see, if I wasn't recording the screen but was recording my face, you'd see my mouth moving, but you wouldn't hear anything. And then electromagnetic waves, they can travel without a medium. So this is X-rays, microwaves, and light, not just sunlight, but light in general. So if you shine a light through a vacuum is what we call it when we're talking about like outer space or something without a medium, light does still travel. So we're going to write down those definitions. You can pause there if you need to. Okay, so transverse waves, and we're going to take a look at this more in just a minute. This is waves in which the particles of the medium move across perpendicular. That's the up and down to the way the wave is moving. So perpendicular is like moving at a right angle. An example is strings on a musical instrument. We're going to take a look at a point of view roller coaster ride. We're going to see that we are moving side to side. And so that is the kind of concept here. The wave is going this direction, left to right across your screen, but the actual wave particles are moving up and down across your screen. So we're going to look at that for this roller coaster point of view. Sorry. Try to get this on the right one. And this is going to be for our transverse waves. So we can see moving left, right, left, right, left, right, left, out here, right, to the left, the right, left. If you get the one, you need to watch the entire thing. And so obviously that is moving differently. We're moving forward on the roller coaster. We're moving left and right as we ride it. So that's what that's looking at there. Okay, so just generically speaking about waves and the types of waves. So our parts of a transverse wave, the crest, that's that high point. The trough is the lowest point between each crest. So the crest is the top portion here. Any of these top portions is a crest. Any of these bottom portions, I just covered it up with that. Any of these bottom portions is a trough. Okay, and then it didn't mention there, the wavelength is the distance between two crests or between two troughs. The wavelength can be measured on top or on bottom, even though it's only labeled on bottom in these notes. Longitudinal wave, you can see the picture kind of looks like a slinky. The longitudinal wave is when the particles move parallel to the direction of the wave motion. So our wave is kind of going whoop, 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 back and forth, and our wave is going all the way forward. And so that is, like I said, like a slinky. So let's get some help from a little guest speaker here. The slinky dog. So right here, he's stretched out. As he goes back, we can see the wave moving the same direction as he moves. Same thing here as he walks, body moving back and forth. So we thank the slinky dog for helping us out understanding that one. So as we look at our longitudinal wave, a little bit different for our parts. The compression, that is going to be this section here where it's actually crammed together. So when we saw a slinky dog walking around, this is when you see, his whole body kind of vibrates as he walks. And so you can see this part grouping together and then spreading apart, grouping together and spreading apart. That's the compression, is when it groups together. The refraction is when it spreads back apart. So that's going to be what you're seeing there, the compression and the refraction. Can you get these concepts in your notes? Okay, so surface wave, this is when both transverse and longitudinal waves combine at or between two media. So they look like transverse waves, but the particle in the medium moves in a circle at the crest, and the particle moves forward. At the trough, it moves backwards. So just to kind of clarify, you can see here the wave is moving in this direction. The bottle leans, straightens out, leans back, straightens out again. So you can see it's actually moving in a circular motion as it actually moves. Okay, so, and this one's got some interaction to it. I am aware of that. Amplitude, it's the maximum distance that the particles of a wave's medium vibrates from their rest position. This is also known as the height of the wave. More amplitude means more energy. And so if this thing can slow down a little bit, can I pause it? No, can't really. So the resting position is going to be this line here in the center. Amplitude is the height or depth. That's why it keeps going or. Height or the depth from that center line to the crest or trough. Okay, wavelength, we talked about that upside down Y is known as wavelength. This is the distance from any point. We mentioned this a little bit earlier in the notes. So from any crest to another crest, or from any trough to another trough. Shorter wavelength equals more energy. Stronger wave means that the wavelengths are closer together. The frequency is how often a wave comes in a given amount of time. This one's measured in hertz. It's named after the scientist who came up with it. His name was Hertz. So 1 hertz means that there is 1 wave per second. Higher frequency, we have a higher energy. This was directly on the diagnostic that we did. We looked at exactly this picture. With closer together lines, that's a higher frequency, and further apart lines, this is a lower frequency. And so that was actually the question, was which one has a higher frequency and why. Higher frequency gives you more energy. It's right here in the notes. And so you can add that into your note sheet. The higher frequency is going to give you more energy because the waves are coming more often. They're closer together. A little bit different than wave speed. So the velocity calculated by multiplying the wavelength and the frequency. So the wave speed and the frequency are not exactly the same. You have to actually look at the wavelength as well to consider that velocity. And here's the formula for that. Velocity equals the frequency times the wavelength. As we shift these things around, that's what gets you your other equations. Try to solve any of those three items in a given math problem. We're going to be looking some more at math problems as we go forward through this unit. So what carries energy? Hint, energy does not travel in a straight line. And it should pause here and you get a chance to fill in that answer. Okay, the universe is made up of only three things, matter, blank, and blank. And once again, it gives you a chance to fill those in. Three states of matter, fill them in. What moves matter? Provide that answer. Okay, like a ball, waves can travel through which of these? Space, gas, liquid, or solid? So which of those things can a ball actually travel through? And unlike a ball, waves also can travel through. Okay, the medium is any matter through which waves travel. Name the media in this room. So just kind of consider what is the matter that we have in this room that waves might travel through. Okay, there's mechanical and electromagnetic waves. Mechanical ones need matter to travel through. Why can't mechanical waves travel through empty space? Okay, question here. Travel through which of the following? If we're looking at both kinds of waves. And unlike mechanical waves, electromagnetic waves can also travel through. So different from this question, this one asks what can they both travel through? This one's just looking at electromagnetic. Okay, now we're going to try to determine a wave speed. Wave has a wavelength of 5 meters and a frequency of 4 hertz. Write your answer in the blank. Okay, and you should have gotten that. That's how you check your answer. Okay, frequency of the wave, 12 centimeters per second and a wavelength of 3 centimeters. It's going to pause you there. You fill in your answer. And there's your check. And finally, speed of a wave that has a wavelength of 2 meters and a frequency of 6 hertz. And you're filling in an answer there. And this one you can add to the end of your notes. Put your answer there and I'll go ahead and check it. Thanks so much.